Okay, this video is on nuclear notation and a little bit on ions, but not in very much detail, and on isotopes. So when we're talking about nuclear notation, we can still get a standard kind of nuclear symbol that we can see on a periodic table, where X is just our symbol. So for example, for helium it's He, lithium it's Li, magnesium it's Mg. So our X is just the symbol, okay, of the element. Oh, there we go. The Z number, okay, this is always the smaller number. Now, most of the time, sometimes it's given on the bottom, but sometimes they can flip them the other way around. Okay, there's always the smaller number. And this is our proton number, okay? Sometimes also known as our atomic number. So we can call it the proton number or we can call it the atomic number. Okay, so proton number or atomic number, so that is our Z value. So for helium, it's 2, lithium, it's 3, and magnesium, it is 12. All right, so that is our proton number. Our A value, all right, is also known as our nucleon number. Okay, in physics, we call it the nucleon number, but in chemistry, they also know this as the atomic mass number. Okay. So for helium, we use 4, lithium 7, magnesium 24. So kind of looking at this helps me understand and know about the structure of the atom of these different elements. Okay, so the Z number always equals the number of protons. Okay, and also for an atom, that would also be the same number of electrons that we have, because remember, in an atom, we have the same number of protons as the same number of electrons, because atoms are neutrally charged. They have an equal number of protons and electrons. Okay, they cancel each other out, so we have no charge there. The A value, okay, is equal to my number of nucleons. In that case, it's the number of protons and the number of neutrons. Okay, so to work out my neutron number, okay, so if N was going to be the number of neutrons, what I would have to do is minus Z away from A. So I do A minus Z. So if we just go through and have a little look at practice working out these ones here. So for helium, my proton number is going to be 2, and therefore my electron number is also 2. To work out my number of neutrons, I need to do my A minus my Z. So 4 minus 2 also gives me 2, okay? For lithium, okay, my Z number is 3, so that means my number of protons is 3 and my number of electrons is 3. Again, I want to work out my number of neutrons, so I have to do A minus Z, so 7 minus 3, which leaves me with 4. Again, if I go to magnesium, my number of protons is 12. Number of electrons have to equal the number of protons, so that's also 12. Magnesium's neutron number, okay, again, A minus Z, so 24 minus 12. Again, that leaves me with 12. So what you'll notice is that sometimes our number of neutrons might equal the number of protons, and sometimes they don't, okay? Sometimes the number of neutrons is greater than the number of protons. When we start getting to really heavy elements, okay, the neutron number is actually a lot bigger than the proton number. We're going to discuss that in another little video called nuclear stability and the NZ stability curve in another video. So as we said here, and what we said in our last video, is that atoms were neutrally charged, they had the same number of protons and electrons. But you might have learned in chemistry before that actually that's not always true. We sometimes can have charged atoms, but that's been really specific. We actually have what we call a charged atom. It's no longer an atom, it's something that we call an ion. Okay, and they become an ion by either gaining or losing the electrons. So we can have a little look at those now. So positive ions, okay, our positive ions are known as cations, okay? A lot of people say cations because they're positive. I don't know, cats have paws. And anions are negative. I always think anions are onions, and onions make you cry. So they're negative, all right? So anion sounds like onion, they make you cry. That's how I remembered them anyway when I was at school. So an example, for an example would be lithium would be a positive ion, because lithium would lose an electron to form a full outer shell. Okay, so if it's lost one electron, it gains one positive. You'll do this in chemistry in a lot more detail. We only really talk about ions in this mini unit when we talk about ionizing radiation. So we don't actually look or do anything on ions. at the moment at least. Negative ions, okay, they must gain electrons. Okay, so cations are positive because they lose electrons, whereas negative ions, they gain electrons. I say negative ions, sorry, gain electrons. So in this case, fluorine, okay, fills in the shape of 2 and then 7, okay, if we're looking at its electron configuration. But we wanted to have it, that's for the atom, okay, for the ion, we wanted to have a full outer shell, so we have to have 2 and 8, so it's gained 1 electron, so it's gained 1 negative charge, so that's an anion. The last thing that we're going to need to know about in terms of like some wording that we're going to use later when we start on nuclear physics is the word isotope. And isotopes can be defined as atoms of the same element. They have the same number of protons, okay, so they have the same Z number, but they have different numbers of neutrons, okay, so their A number is different. So if we look down here, you can see that we've got different numbers for our A number. So these are 3 isotopes of hydrogen and 3 isotopes of carbon. Okay, so hydrogen 1, 1. Okay, if I did protons and neutrons for each of these, again, we could say proton has 1. For this one, the proton also is 1. For this one, the proton is 1. For this one, the neutron is 0. For this one, the neutron is 1. And for this one, the neutron is 2. Again, if I look at carbon down here and I did the protons and neutrons, okay, again, each of these 6, 6 and 6, I'm looking at the Z number each time, and then our number of neutrons, okay, my A take away my Z leaves me with 6, my A take away my Z leaves me with 7, and my A take away my Z leaves me with 8. Okay, so again, with this, I've got the same number of protons, but different numbers of neutrons. Now, we're going to be using isotopes later when we talk about unstable nuclei, and we'll have different isotopes of different elements, and some are more stable and less stable, okay, and some are more commonly occurring because they're more stable and they don't decay, whereas unstable isotopes decay. All right, so that's what we're going to be looking at later with our nuclear physics unit.